Good afternoon, guys. So we are going to look at solving trig equations, but this time using the cast diagram. So the cast diagram is just a tool that was kind of created to help us solve trig equations in a slightly easier fashion. So this is kind of the beginning steps of it. So if you go into like further maths or A-level maths, it will increase in the level of difficulty, but this is more of a basic level. So rather than using graphs and intercepting, so rather than saying, oh, well, I've got y equals sine x and y equals a half, and where do they intercept? This time we can actually use a cast diagram. So where it actually comes about is you are talking about the angles. So in this case, because all of these questions, I believe they go through 0 and 360. Okay, so I'm just going by the top section, which goes between 0 and 360. Okay, so where you usually see the x-axis, that's going to be our 0. Okay, and then you have to move counterclockwise or anti-clockwise, however you want to say it, and you just go up in steps of 90 degrees. Okay, hopefully that should make sense. Okay, so now we just want to insert the sine, cosine, and the tangent. So if I look at the sine, I would say between 0 and 90, is it positive or negative? Well, it's above the x-axis, so this would be positive. Okay, for the second quarter, which is between 90 and 180, which is this quarter right here, it is still positive. Okay, for the third quarter between 180 and 270, which is this one, you can see that it's negative, so I'm going to put negative. And then for this fourth quarter, again between 270 and 360, it is negative. Okay, and then we do the same steps for cosine as well as tangent. So for cosine, between 0 and 90 is positive. Between 90 and 180, it is negative. Between 180 and 270, it's still negative. And then between 270 and 360, it is positive. Okay, and last but not least, we have our tangent. So tangent between 0 and 90 is positive. Between 90 and 180, it is negative. Between 180 and 270, it is positive. And between 270 and 360, it is negative. Okay, so all you need to know is what is positive in each of those quadrants. So for this quadrant, all of them are positive. Okay, for this quadrant, only the cosine is positive. For this quadrant, only the tangent is positive. And for this quadrant, only the sine is positive. So you should see CAST. So this is the reason why it's called a cast diagram, because when you are using this diagram, I know that if I have an angle in here, the cosine is positive, but none of the other trig functions are. For up here, all of them are positive. If I have an angle within there, all of them will be positive. If I have an angle in here, only sine is positive, the other two are negative. And for down here, only tangent is positive and the other two are negative. That is the reason why it's called a cast diagram. I just thought I would show you these graphs just to help you understand where this kind of comes from. But now we're just going to move on to checking out some of those questions and how you would do it using a cast diagram. Okay, so we are going to look at these questions. You'll probably notice I didn't really go into question 1 because it's got zeros and ones in it, and when you are trying to solve zeros or ones, unless it's tangent, for tan theta equals 1, you really just want to be using the trig graphs. If you use the trig graphs, it's much easier because then you can get the intercepts. Whereas sine 0, if you remember the trig graph, will be at 0, 180, and 360. And you wouldn't be able to represent that on a cast diagram because the cast diagram, this is 0, so you wouldn't be able to represent that 0. It's between two of these. This is 90, so you wouldn't be able to represent that. This is 180, so you couldn't really represent that. It needs to be otherwise less than 180 or more than 180. It wouldn't be 180 exact. So if you do find any of the angles that are exactly at that angle, it's easier to go to a graph than it is to use the cast diagram. Okay, so anyway, we have sin theta equals 0.5. So this is where you can use the fabulous calculator. So we need to just say, well, if that equals 0.5, then theta equals, some of you might remember your exact angles, but theta should just equal 30 degrees, okay? So if this is 0, that's 90, this is 180, and this is 270, and then this goes into 360. First of all, I need to draw out that 30 degrees. So 30 degrees is just here. Okay, and because it says sine, that means I'm going to look for the other corresponding sign. Okay, so in this one, sine is positive. So I need to look for the other quadrant where sine is positive. Okay, so the other quadrant where sine is positive is this one. So what I need to do, I need to draw an angle to the actual horizontal line that is the same as whatever this one is. So this one is also 30 degrees in comparison to that. But obviously that angle is not going to be 30 degrees because I don't measure 0 from here. I would measure it from here. So for this angle, I would measure that. Okay, so although this is 30, which is symmetrical to that one, the angle itself would be 150. Okay, so if you're not sure about that, you can obviously type it into your calculator. So you could just say sine 150, and then you do get 0.5 for that as well, okay? So that is the way you would get both of those angles. So I would say 30 degrees or 150. Okay, so another one, we have cosine. Cosine theta equals a half. Okay, so I'm going to draw my cast diagram again. Okay, so first of all, I'm going to say, well, what is the inverse of cosine a half? It is 60 degrees. Yep, 60 degrees. Okay, so 60 degrees, this is 0, this is 90, so I know 60 degrees is going to be in there. So I need to find the other quadrant that also has, because cosine is positive in there, I need the other quadrant where cosine is also positive, which is this one just down here. So I need to draw 60 degrees to the horizontal again. But obviously this 60 degrees is not my angle. The angle will be all the way from 0 all the way over here, okay? Which is 300 degrees. So my answers will be theta is 60 degrees or it's 300 degrees. Okay, I'll go through a couple more examples. But hopefully it's starting to make a little bit of sense. Honestly, cast diagram is one of those things that kind of makes no sense until you just go, oh, and then all of a sudden it makes sense. Okay, so what's the next one? Tangent 1 over tangent theta, which is 1 over root 3. Okay, so I've got my cast. Let me just type in 1 over root 3, close bracket. Okay, so there you just do the inverse for the first one. So it's telling me that 30 degrees, that means between the 0, 90, 180, and 270, and that's 360. Okay, so 30 degrees is between 0 and 90. So there's my 30 degrees in there. Okay, so because it's tangent, tan is positive in this quadrant. So find the other quadrant where tan is also positive, which is this one just down here. Okay, so I'm going to do 30 degrees to the horizontal. And then in order to find out what that angle is, I would take it all the way from 0 and measure it around. Okay, so this would be 180 plus the 30 degrees, which is 210. So my answer is 30 degrees and 210. If you're ever in doubt about the second angle, just pop it into your calculator. If you pop it into your calculator, it will just come out with this answer, which is the answer you're expecting. Okay, so next one is sine theta equals 1 over root 2. Okay, so we have the cast diagram, 0, 90, 180, 270. I always make it a habit to write down the angle, especially when you're moving into A-levels or anything else, because you have degrees and you have radians. It's always good to write down the angle. That way you don't get confused when someone gives you an angle. Because at A-level especially, this will move into radians, okay? But for right now, because it's degrees, you want to stick with degrees. But I know quite a few people work in degrees, and so just to make sure that you are doing it correctly and you don't get the conversion incorrect, label up the angles. Okay, so you got 1 over, did I put root 2? Should be root 2, right? Yes, root 2. Okay, so I know this angle is 45 degrees, so between 0 and 90, that is 45 degrees. Because it's sine, I'm looking for the other positive quadrant that contains sine, which is this one right here. So this is 45 degrees. So this will be 135 degrees. Okay, so my two angles will be 45 degrees and 135 degrees. Okay, hopefully that makes sense. The thing about cast diagrams as well, the cast diagrams mean that you don't actually have to draw out graphs. So I would say generically, the way I usually work is I know the sketch of the graph, so I know my intersections, but this way is much easier if all you need is a quick sketch, because you'll notice I'm not doing anything exact, and kind of that doesn't look like 30 degrees, but it's near there. This doesn't look exactly like 45 degrees, sorry, it's just a sketch, okay? So the thing about the cast diagram, I can quickly do a sketch and it kind of shows all my working out for me. But hopefully that should be fine. I don't mind working through a few more if you kind of don't get it, and I'll have one with more examples if needed. But for right now, I think you should be fine with however many examples we've done. So what I'm doing is I'm going to set you some questions, and you just need to answer them. Have fun and enjoy the rest of your day. Doodle!